Cool, we'll get going. Afternoon, everyone. Hope NDC's been treating you well. Today I'm going to be chatting about what I find actually quite an interesting space is the evolution of infrastructure as code. It's an area that's got heaps and heaps of focus recently and gained a lot of maturity, but most of the different options are relatively the same. There hasn't been many large steps. There's been a heap of kind of supporting infrastructure, way more modules, less bugs, kind of a lot of maturity, but nearly everything is defined in YAML, and I'm not a massive fan of YAML. There's someone at the conference, Jeffrey Huntley, who built this site, noyaml.com, and it's a collection of reasons that YAML is not a good idea. One of the little snippets is how big the spec is. So 23,000 lines, bigger than XML. JSON's pretty tiny, but it's a bit of a monster. It's like 24 ways to define a Boolean. And then you talk to ops people and they're like, yeah, but why would you use all of YAML? And then we kind of get this. We've seen this one before. A little bit of context about me, for those who have not met me. I am Jake Ginnivan. I'm based at 7 West Media in Perth. I'm the tech lead there. And hit me up on Twitter if you've got any questions. And also, as we're going, if there's something that you'd like me to clarify, just throw your hand up. Happy to take questions as we go. But a bit of context about me. I'm mainly a dev. So I'm not a production engineer. I spend most of my time building software, and I do work with production engineers and have to be in AWS, and I understand our architecture and work on it, but that's not my primary role. It's one of my functions. So the way I describe myself is I do some production engineering, but I'm not a production engineer. So that gives you a little bit of context about me, and I think it's quite important to frame up why I'm excited about the tool we're going to be talking today about is Pulumi. But first we'll jump into Terraform. So who's used Terraform here? Cool. So this is, Terraform just doesn't fit with my mental model very well because say we want to deal with a list, I want to create a few users. Because it's a templating language, we have to use kind of array syntax, and then for each item in that list, it will kind of duplicate and then execute that template at the end. The engine will execute it. It's not the way I think and not the way I approach problems. So whenever I jump into Terraform, it's normally every month or two. I'm not constantly in there, and it requires a huge amount of context for me just to pick it up and kind of figure out, okay, that's the way loops or conditionals or whatever hack it is to try and get some of these control flow structures working in a templating or a configuration language, which is YAML. So then start asking what the guys at Plumie sort of were like, what if we could actually define our resources in code? What would that look like? Well, there's a lot of things we start getting for free. So we get package management. So Pulumi allows you to write all of your infrastructure modules in a couple of languages. I'm going to be focusing mainly today on TypeScript because that's what I use, but you can also write all of your infrastructure in Python or Go. Pulumi's engine is separated from kind of the front end that you declare everything in, and so it has a step, runs your program, and then sends it off to the engine. So all of these languages are decoupled from the engine, and that's where the sort of infrastructure as code sort of smarts are. So we get package management for NPM. I can just compile my TypeScript and put it in a NPM module, push it up to either public or Nexus, and now I can share my infrastructure modules just like I could my normal code. If I've got config flags that do different things in different environments, so in production, I want a whole bunch of alerting set up. I don't want all of those alerts set up in dev. I can just have a config flag that says enable alerts, and then put that in the if block, and now all of my alerts are hidden behind that config flag. We can just use if statements and loops and the sort of normal programming constructs that we're used to. We've also got testing. There's an interesting article which allows you to, use Mocha and Jest to test your infrastructure using sort of JavaScript test tools. So it opens up a whole bunch of problems that in, say, the Terraform world, they've had to solve by expanding what you can do in the templating language or adding in little functions to the CLI and whatnot. Whole bunch of this stuff, if we coded our resources in code, just we get for free. What does that actually look like, though? We're importing, we use AWS at work, so whenever I'm talking about AWS, there are modules in Pulumi for Azure, Google Cloud, and then they also have another one which is just a cloud abstraction. So you can just program against the cloud and it will sort of create the same resources in whichever cloud you happen to configure. So we import our AWS module and then we just declare an array with 2 users in it. I then loop through the users and then I new up an IAM role. So this is a really weird concept. It's like, whoa, what's going on? I thought you were talking about infrastructure as code. When I think about infrastructure as code, it's normally declarative. What I think about is I declare my infrastructure and then some engine makes sure that the desired state happens in production or in the actual cloud vendor. This looks very imperative. It doesn't quite fit what I'm used to. But the end result is actually the same. So what Pulumi does is you have your development cycle, you build your program. When you new up a resource, it kind of registers that you want that resource. So when your program executes, it actually does nothing apart from tell Pulumi that I want an IAM role. So that's kind of the development cycle. I then can go and plan, and this is much same as a Terraform plan, where it will show you, okay, here are all the resources that you registered that you want. I'm going to diff that with production, and these are all the changes that will happen in production if you say yes. And then finally you deploy it, and it will go make those changes. So we're using a kind of imperative, writing a program and newing up resources, and then using those resources that we've created in code becomes the desired state. Diving a little bit deeper, the way we do that is just run the command Plumie up. It'll then give you a preview of what's going to happen. So I've got to create the role Bob, role Jake, 2 resources are going to be created, and then I can just say yes. So those familiar with Terraform, much the same flow. In fact, Pulumi, a lot of Pulumi's modules just wrap Terraform modules. So a lot of the hard work that's gone into building Terraform and making these abstractions for the different cloud APIs, Pulumi's leveraging that. Before we get into the code, there's quite a few concepts that I kind of had to get my head around when starting to use it. And a bit more context about me. I actually only got into Pulumi a couple of months ago. I was at a conference in Kansas City talking with one of the devs there who works at Pulumi, and he was showing me it. Got pretty excited, and that's where I was like, oh, well, I really want to learn this, so I submitted a talk to MDC, and here we are. So I've spent the last month or 2 learning it to make sure that I could explain it well. And these are the concepts that kind of hit me as the things that weren't immediately obvious, and once I got a mental model around that, everything became way easier. The first thing to get your head around is the way Plumie projects work. So you can create multiple projects. Each project is essentially a program. It has, in the TypeScript world, it has an index.ts file, and that is your Pulumi project. You define all the resources in that by newing them up. But how do you actually get that into an environment? They have a concept called stacks. So a stack is kind of an environment, but it doesn't have to map one-to-one. So I could create a dev stack, a production stack, and they can also be named arbitrarily. You then have another layer on top, which is organization. And organization by default will just be you, but you can configure it to be, if you work at a company, your company, and that sort of stuff. So this is the kind of structure of stacks and projects. and we'll dive into that a little bit soon. And then, so when I create a bunch of resources in my project, I can then say Pulumi up for a particular stack in a project, and then it will go create those resources in wherever you've declared. Let's have a quick look at projects and stacks. Oops. So first thing to do is we're just going to make a directory, which is demo, go into demo, and then just go Pulumi new. Can everyone see the terminal? Text is big enough? Excellent. So when you go Pulumi new, it'll give you a whole bunch of different templates. So you can see here, there's ones for Azure and in JavaScript, Python. So I'm just going to say AWS TypeScript. It'll ask you for a name, a program, and then it will ask you for a stack. So by default, it's just going to say dev. So that's fine. We're going to use AP Southeast 2, which is Sydney. And then it'll go off and install all the Plumie modules for you. Great. So it's created a few things. You've got your index.ts file. So if we have a quick look at that, the default template just creates an S3 bucket. We can then go Pulumi stack select. Oops. And so you can see I have one stack, which is dev, and then I could create a new stack, which is prod, and this is kind of how you manage your environments with a project. So that's a quick rundown of projects and stacks. So you'll end up having quite a lot of stacks. The Pulumi CLI is most of the time is what you'll be interacting with, but there's a bunch of stuff under the covers. It has to be backed by some sort of state. Because we're essentially infrastructure as code with desired state, it needs to know what the current state is in the cloud. I've always wondered a little bit around, okay, why don't they just query directly, and why do you have an intermediary state store? There's actually a bunch of extra stuff that gets stored. So, and the APIs don't always allow you just to attach random metadata to every type of resource. And some resources are also logical resources, so they don't exist in the cloud. They kind of exist in your programming model. That's the best. I haven't seen anything that says otherwise, but that's my best guess on that. If anyone else has theories, let me know. So your Pulumi state has to be stored somewhere. You can choose, there's a number of them, but the most common three in S3. This is quite a common practice in Terraform, but Pulumi doesn't yet support locking in S3. Like, you can't use a Dynamo table and support locks. So if you're using S3, be careful. Don't have people trying to run Pulumi up at the same time. Otherwise, you'll have a really bad time. You have app.pulumi.com. So this is their managed service for state management. So it handles locking, storing all your state, and a whole bunch of other things, which I'll jump into a little bit later. And you can also just use state on your local machine, which awesome for dev, because it just drops it on your machine. But if you lose your state, you're going to have a hard time. There are implications for using Pulumi's managed service. It does cost. I'll cover that in a minute. So you get started, log in to one of these state stores. You have to make a decision early, and then all of the state will be put in there. There's some cool things with state as well. Pulumi have actually built tools that allow you to import, say, Terraform state into Pulumi, and they have a bunch of work around interoperating with Terraform state. So you can continue using Terraform in your own projects, and then if you want to create like one new service off to the side using Pulumi, it can actually query the state inside Terraform and reference kind of your ARNs and get at infrastructure that was created by something else, which is really cool. So when you run Pulumi up, it will ask the state, do I have some state for this project and stack as a combination? And then it'll say yes or no. From there, the engine can make it do all the diffing and figure out what needs to be created, and then off it goes. It creates all of the things. I said I'd get back to Plumie, app.plumie.com. It's quite an interesting offering, and the way my mental model of it is a service for managing your infrastructure. So there's two sides of Plumie. There's the Plumie SDK. So this is the engine. This is all of the SDKs around wrapping AWS and these various services. And then you have app.plumie.com. So your open source, your SDKs are all open source. They're going to be free forever. And they are kind of the essence of they're the infrastructure as code. They're all the smarts and they make it all work. It's free as long as you don't use Pulumi.com in a team. So there's free tiers. It's free for personal projects. And if you want to use it for yourself, it's fine. But as soon as you want to use it in a team, you have to pay for it. But it does come with some really, really interesting features. So audit history, so you can see exactly what infrastructure changes have been made across all your environments. Infrastructure policies is really, really cool. So if you want to deprecate a version of Node or make sure that all of your log rotation settings have a certain expiry time, or any number of things, you can actually create these policies and then they'll be enforced across all of your Pulumi projects. So you can deprecate usage of something and then you'll be able to audit your entire infrastructure to see what doesn't meet that policy, and new infrastructure can't be created that actually violates those policies. So that's really handy. Does secrets management, and also you can see all of your projects and stacks in one spot. Gives you a nice dependency graph and allows you to kind of work at your project level, which is really handy. Let's actually do some code because I've been talking for ages. So we're going to build a static site generator. This is one of the things that's really interesting about Plumie. Because we're using a programming language, we can start building abstractions and smarts into things, and kind of use a lot of the things we're used to. We're composing things together, and we can also infer a huge amount of stuff. So here I want to create an S3 bucket that also serves HTML files. That's really easy to do. I can just say, I want an S3 bucket. These names can be anything. They're not important. They're kind of a logical name for each of these resources. And then I can say, okay, I want it to be a website. My index document is index.html. And I also just want to say, if you Plumie destroy, it's okay to destroy the bucket. But where it gets really interesting is I can go bucket.onObjectCreated. I'm going to, which is a event handler, give it a name, and then I'm going to give it a lambda function. So in here, it's just an event handler written in JavaScript. I can access the S3 event. I can require modules, so I'm requiring a markdown parser. I'm then using the AWS SDK to connect to S3. Then for every record that's been created in this event, if it's a markdown file, I'll go grab the body of that markdown file. I will parse the markdown into HTML, and then I'll wrap it in an HTML body. So I'm creating an HTML file on the fly in an event handler, and then I'm putting it back into S3. So you have to think about what it's trying to do here. So what Pulumi will do is when I run Pulumi up, it'll see that there's an event handler. It will extract that code, make sure that any references to Pulumi state, so the S3 bucket name, becomes config. It'll then upload that zip file, create the lambda behind the scenes, and so when the lambda executes, it will execute the code that we've written here. It's kind of a mind-boggling thing that now I've got my application code and my infrastructure code actually in the same program. You'd probably extract this out to another module and just require it in here. But yeah, we can use normal JavaScript modules and refactor things just as we'd want. There's another thing I wanted to do was be able to just have a CSS file and some random other files. So I just go through, crawl the directory, so the assets, the files path, and then recursively I will put anything I find as an S3 bucket object. So we will create a stack. And we will Pulumi up. If this takes too long, I've forgotten a step. There we go. So first thing it'll do is tell you I'm missing config. So I have to tell it what region I want to put this into. So I'll Pulumi config set AWS region to AP Southeast 2. And you'll see as soon as I do that, it will create me another YAML file. Can't get away from YAML. Irony. It'll create me a config file that this is where all of your application config will go. So config is scoped, so you can kind of create namespaces on your config, and the SDK kind of allows you to work with those namespaces pretty easily. So that's all there is to the config side of things. So I'll Plumie up again. When we run the larger demos, we won't wait. So you can see it's actually creating a fair amount of stuff here. My S3 bucket and my Lambda down here. And then it's also created the IAM roles, the policy attachment, and the bucket notifications to actually wire all this stuff together. And it can infer that quite easily because I've just put the event handler onto the bucket. It knows that if the bucket raises an event, it needs to execute the Lambda, and there's a whole bunch of permissions and stuff that need to be set. It can do all that for you. The next really nice thing is once this will take a second to run, but if you want to make the bucket name and various different bits of output available, you can just export them using normal JavaScript exports. So as soon as you can see that it's creating the bucket, it's also uploaded my main.css into that bucket. And what's really cool is in here, it knows that I'm creating the bucket object in this bucket. So it'll take care of creating its own dependency graph and making sure that things are created in the right order. So you can see this is my public URL for my bucket. And if I go over to Firefox, 404 makes sense. So in my AWS console, I'm going to go to S3. And you can see that my bucket was 27512. So this one. If I just upload a file, I'm going to upload index.markdown or MD. It's there. I'll just wait a second, refresh a couple of times, and my HTML file appears. Woo! If I refresh again, there is my markdown file that has been turned into. So that's the markdown file that I just uploaded, and this is the HTML file that got generated, served out of S3. There's quite a few moving parts there, but I reckon that's kind of your iconic Plumie demo of all of these, the advantages, I suppose, of writing your infrastructure in a programming language. It's okay, but what's going on here? So what's actually happened? So we created an S3 bucket and a Lambda. We uploaded our CSS file, which is managed. So if I make changes to that, it'll update it. If I delete that file, it'll get removed from S3. So that files folder is now managed by Pulumi. Everything I create in there will end up in that S3 bucket. It's created as a subscription, and all the permissions and everything to be able to execute that Lambda. It also set up the permissions, so the S3 or the Lambda can write files back into S3. And then whenever I upload a markdown file, it'll pretty much run that-ish code. If it's markdown file, grab it, change it, put it back. Pretty nifty. And then I can export values for later referencing. It's okay, but this is kind of a happy demo. I've been working at West now for 3 years, and we have a lot of infrastructure, a lot of legacy. And so I really wanted to try and figure out, okay, can Pulumi do better for us than what we currently have? So we're going to dive in and actually go a little bit deeper. So these are the 3 websites my team builds. We build 7news.com.au, the West, and Perth Now. So they're quite large sites, have a lot of traffic, but our infrastructure hasn't really changed the way we host them for about 3 years. Really want to change that. Our Git repo structure is something along these lines. We have a bunch of application repositories and we have some infrastructure repositories. They're managed by, we sit next to and collaborate with our ops team all the time. Most of the dev team don't get involved and don't actually write Terraform and touch anything in these infrastructure repositories. So we have one which has all the Terraform, and then because we're using EC2, it's managed by Puppet, and all of our configuration kind of lives inside Puppet. It's quite a traditional model. We then have 3 main repos. We have the web repo, and so that has the code base, a big shared component library, and then a code base for each of the websites. And then we have an API repo, and then we have a content aggregator repo. So that kind of looks at all of these different news feeds, our CMS, and broadcasts events that our different APIs then store in their database. So I've got a couple of goals. These are the things I want to do. I want the dev team maintaining the infrastructure. I want to work with our ops team, make sure that everything's monitored well, that it's architected the way that they kind of input to that. But I really want the dev team to be able to evolve the architecture and also just make improvements and save costs in the infrastructure. I really want it co-located with the code, because at the moment our infrastructure is kind of out of sight, out of mind, and that's why a lot of the dev team don't work on it, because it's not there, it's not front of mind. Wanted to reduce costs, but the biggest thing that I really, really want is I want to enable an architecture that we can get blue-green deployment. It's quite hard to do that with EC2 because it's just quite heavy and slow. Roughly what our website's deployment structure kind of looks like is we have a stack for each website. Each website has its own database, its own APIs, and then we have one aggregator and some messages flowing through. So this is kind of what we're working with, and this is a pretty typical application architecture, I'd imagine. You've got a website, you've got an API, it's backed by a database. So let's rethink this. What could we do instead of all of those things being stored on like EC2 instances? I want to use 2 technologies. I want to use Fargate, which is essentially Docker as a service. You can write a Docker file, and then you build the image. You put it up in a Docker repository in AWS, and then you can say, hey, Fargate, run this container. And you don't have to worry about provisioning the compute behind it. You just get charged for how long it's running. They also have ECS, which you manage all the compute yourself. But this is kind of the closest thing I think AWS has to app services in Azure. So that's what I want. I want to be able to just create all of these containers and just say, hey, Fargate, run them. It also opens up some really interesting capabilities. For all of our front-end code, whenever we put up a pull request, we build a Docker image and deploy it and post links. So we can actually test the full running website for each of those, for every single pull request. What we don't have is that for our backends and our kind of APIs. Would be really, really good. So hopefully this architecture will allow us to solve that problem. And then I wanted to play around with Aurora, which is their kind of managed compatible RDS with Postgres and MySQL, but it can scale out horizontally rather than vertically. So your traditional RDSs like Postgres and MySQL, they don't support clustering and farming out work on all of these different instances without a fair bit of work. They're not architected in that way. Aurora is. If we're going back to sort of Pulumi concepts, this is the way I'd envisage it. Over on the right, I'd have a content platform shared. So that would be my shared infrastructure, my Aurora cluster and my Fargate cluster. I can then deploy multiple instances of the web and content APIs into that shared infrastructure, and then I would deploy one content aggregator. There's also a bunch of other things like load balancers, queues, permissions, a whole bunch of extra stuff. But we are going to focus on a subset of that. And then in terms of those are my projects, my stacks would be something like this. So I have a prod and dev stack for the shared stuff, but I would have a stack for each masthead in each environment for the websites. We're going to pare it down a little bit. We'll just do the content APIs, the database, and the shared infrastructure. So, content platform shared. What does that look like? So we have in here my shared infrastructure. We're going to start diving in, and so if anyone has any questions, I'm just going to be going through a lot of this code, explaining quite a few concepts, and then we'll do a bit of a recap after. So if there's something that doesn't make sense, please just throw up your hand. We've seen this before. We can new up a resource. What might be confusing initially is you've got two namespaces. You've got AWS and AWS X. So Plumie has this concept of what they call crosswalk, and it's a kind of batteries included infrastructure as code. So here I can go awsx.ecs.cluster, or I can new up aws.ecs.cluster. Look, it's TypeScript. I get IntelliSense. It's amazing. So I can also new up a cluster out of the normal SDK. The difference is that when I new up the AWS X, it has a bunch of sensible defaults. So it will create a VPC, which is a private network for all of our services. It will create a VPC for my stack. It will then make sure it's all associated. It'll create a bunch of default subnets and security groups and stuff that when you're first getting into AWS, it's just there's so much to learn and what are the best practices. Pulumi Crosswalk kind of takes all of that away. So you can just say, I want a new cluster, and it will do reasonably sensible things. You can see here, I can ask for my security groups. So these are the security groups it's created. I can also create a subnet group, which has all of the public subnets. And this is important because when I start my Fargate containers later, I want them to be on the same network so everything can talk to each other. With the database, you can just new up an RDS cluster. Notice it's from AWS, not AWS X. I'll just bump that up for everyone. I can specify the engine and a whole bunch of stuff. Obviously, don't do that like I have, but it's in a it's not public, so that doesn't really matter. And there's a whole bunch of other stuff. You've got all of these things you can configure, play around with it. My cluster, my Aurora cluster, needs to be backed by an instance so it can actually run my compute. And then finally, I can export the Fargate cluster name, the VPC ID, a bunch of security group IDs, and the database provider ID. So these are all kind of references to the infrastructure that's created. You'll notice here that there is Pulumi output. This is This is something that is a really, really important concept. Because you're dealing with futures, like this, at the time you're writing the program, that variable doesn't exist. There is no ID until I've done my deployment and that infrastructure has been created. So this output type allows you to work with variables that have no value yet. So if we go ahead and do the normal Pulumi stack select, oops, and then shared, I've got a fallback one just in case things go horribly. So we'll create a demo stack. I will Pulumi config set AWS region as AP Southeast 2. I make the same typo every single time. And then I will Pulumi up my shared infrastructure. Once again, it's TypeScript. If I make mistakes, typos, Plumie will actually compile this and give me type errors. It's just doing the plan. I won't make you sit through the actual deploy. So you can see it's actually created a whole bunch of stuff. So it's created ingress and egress security groups and roles. It's created a default VPC, and it's created a public subnet for it. So I'm going to go ahead and create this, and we will jump back here for a moment. So we talked about Plumie Crosswalk. That's the AWS X namespace. So new up the cluster, and it creates a bunch of like ECS cluster, VPC, security groups, that sort of thing. So very, very useful for, I just want sensible defaults. I don't really care. And then you can, if you want, you can create your own VPC and say, use this VPC and kind of override all of those defaults if you would like. And then you've got Plumie AWS. So they've got a number of cloud SDKs, and this allows you to just new up resources. So lower level, you can choose what level of abstraction you want to work with. So the next thing we're going to do is create the content APIs. And there's immediately a problem. I've created some shared infrastructure. How do I use that in my other project? It has a really cool concept just called stack references. So you can just new up a stack reference, give it a path to the project and the stack that you want to reference, and then it will allow you to access any exported variables. So that kind of solves our first problem. We can access and just get the IDs of any infrastructure that was created in another project, and it will actually go and query the Pulumi state. So that's why we need a shared state store that has all of the state for all projects and stacks. The next one, which is my favorite one because it's a pain and it's really difficult to get right, is database migrations. And this is annoyingly not talked about anywhere because I think it's quite a hard problem. Most people, and the way we're solving it now, is it's an out-of-band process. So whenever we create a new environment, we go in, create the database, and then in our deployment step, we have rules so we can connect to, like the build server can connect to our database, and then our build server runs our database migrations, and then it does all the deployments. I wanted to sort of spin the tires on Pulumi a little bit and move our database migrations and also the creation of the database itself into Pulumi. So that's been my main task. There's a couple of problems. So I don't want to connect. I don't want to make my database public. So that's what most of the Terraform modules, they just connect to the database and then they can create it. I don't want to do that. I don't want my machine to be connecting to the database and running it. I want something else to run it. And also, I'd like it to be cleaned up. If I pass a flag to say, yep, it's all good to delete the database after, I want to be able to opt in to allow it to clean the database up. So this is super easy to manage the database cluster, but creating a multi-tenanted database with multiple in it is really, really annoying. So my solution to this is Fargate tasks. So I can have services in Fargate where it starts up the container and they keep running. But you can also just tell Fargate to run a container. It will run and then exit. So it kind of allows me to just execute arbitrary commands in the cloud, which is kind of nifty. It also runs inside the network that is created inside AWS. So I don't have to open up my database to the public, and I get kind of IAM, so I don't need to use username and passwords. I can use inbuilt authentication and a bunch of other stuff. What would that actually look like? So my solution to this was I created a few task definitions inside. They're basically just Docker containers or Docker images that aren't running. So I can create task DB task definition, a drop database task definition, and a migrate database task definition. That's all good, easy to do in Pulumi. What about running it? This is the bit that is a pain in the ass. So no way. Luckily, being a programming language, there are some really cool things we can start doing. Pulumi's solution to get out of jail free or whatever, escape hatch kind of thing, is something called a dynamic resource. So that allows me to wrap APIs. It allows you to implement your create, your update, delete, your diff, and check functions. So you essentially can program a resource that just has arbitrary kind of CRUD-based APIs. There's some cool examples around managing GitHub labels. If you run open source projects and you want them all to have the same labels, you could actually manage your GitHub labels inside Pulumi, create a dynamic resource that creates and updates those labels inside GitHub. Also creating and deleting webhooks, or just wrapping the AWS SDK, which is what we're going to do. So pulling it all together, we have Fargate. When I create my task definitions, this is what we've kind of seen, and then it runs the create DB task, waits for it to exit. It'll then run the migrate DB task. I'll show you how we can kind of define relationships in a sec. And then once it's complete, it'll run the task. We can then, if we're doing Plumie up, it will just run them again. So create DB again. It's idempotent, the database exists, won't do anything. Once that's done, it'll run the database migrations again, and then destroy the opposite. Because it knows that the run task relies on the task definition, it'll be cleaned up before, or we'll execute the task before we delete the task. So it's kind of a whole bunch of stuff. So let's have a look at that. Cool. Before we do, I'm just going to show you what Plumie.com gives us. So I've jumped in. It gives us a nice deployment notification and all of the things that were created. I can have a look at all the resources that it's managing, and I can jump straight out to that resource in AWS console, and it also gives us kind of a graph of all of the different things it's created. So this is Plumie.com, gives you kind of that abstraction over the top. And you can also see here are the outputs that it has given me. What we're going to do is, and you can see this is what we created earlier. It went and successfully did it. So I'm going to kick off our app while we're talking. Region, AP, Southeast 2. And then we'll Pulumi up. Okay, let's have a look at our app. We'll get to this in a sec. So the first thing you'll notice is I can say Pulumi get stack, and that will actually just return me whatever my current stack. So because I'm running my currently selected stack is demo, the value of env will be demo. This allows me to access the config of my project. So if I was to have custom config, I could. We'll let that go because that takes a little while. And then we can see the stack reference. So we talked about organizations earlier, and by default it is me. So I am the organization. You then can just specify the project name. So back over in the shared project, we have the name of this project. So I can specify the project name, and then I can go / the stack name. So here I want to get the config value of shared stack name. So this will allow me to, okay, my shared is called dev, but my app is called dev-perth now. I want to be able to specify that. We've got the same stack name, so we're just going to default to that right now for the demo. We can then say I require this output variable from my other stack. So I'm getting the Fargate cluster name and the database provider ID. It also has static functions on all of these AWS and different cloud resources to get an existing resource. So this is how you can get a full Pulumi object with all the APIs and functions and all that sort of stuff without having Pulumi access it. This is also really handy for if you want to reference existing infrastructure that's not managed by Plumie. You can just put the ARNs in here and then off you go. So I'm going to create my cluster. You'll notice that I'm overriding the cluster, which is the underlying resource, so crosswalk and then the normal one. And then I get to my content API database. So this is a custom thing I've built. It requires me to pass in my Aurora instance, the cluster, specify a database name. My database name is just going to be the stack, so we demo. I need to specify the master password because it won't come across. And then I can specify in config, enable drop and recreate. So this kind of allows me to choose to be able to clean up the database. Let's have a quick look at that. So this is another new concept, component resource. Because we're in a programming language, I want to just compose a number of resources together and make a new logical resource. That's what component resources are. So in your constructor, I can new up other things, so Fargate task definition, for instance, and then I can just say the parent of that is this object. And now you get the Content API database as a resource with a whole bunch of sub-resources under it. We were talking about the output variables earlier. You'll notice here I'm doing this weird Pulumi all and passing an array of things in. You can't just interpolate something that doesn't exist. So I want to build a connection string here, but at the point of like the first time I run, I don't have a database name to put in the connection string. I don't have an endpoint. So this Pulumi.all and a Pulumi.apply allows you to pass in output variables and then create a new output variable when it's available. So this allows me to take in master username, master password, and the endpoint, and then apply, merge them together, create a connection string. We've got nice inbuilt support for containers, so I can actually just say AWS ECS image from path and give it a path, and that will find the Docker file, build the Docker file, upload it into ECR, and make that container available for other parts of my services, which is the Fargate task definition, which I can just specify the image that I want this task to run. I'm then overriding the command, so I'm going to call my little database migrator, passing in a create database function. Drop database is the same. And now this is how I've decided I'm going to create the database. I'm creating a new Fargate task. I'm passing in a task definition and a cluster to run it on. But what's also really cool is I can specify depends on. And you can just say this resource depends on another one. And now Pulumi will make sure it doesn't create this one before the other one's created. I can't run my database migrations until I have a database. That's kind of problem. So let's have a look at this Fargate task. So this is this dynamic resource I was talking about earlier. it allows me to, in the constructor, do a bunch of parsing around the config, but all of this is just config. What's really interesting is this resource provider. So if I go into my resource provider, this is what actually allows me to implement my own resources. So what I've done is create function, and I just call run Fargate task. What run Fargate task does is it uses the AWS SDK. So we've stepped away from Pulumi. I'm now just using the raw node AWS SDK, and I say run this task. And then I have a whole bunch of error checking because you can run multiple tasks and whatnot. But then I can say ECS wait for this task to enter a stopped state. And it'll just sit there polling until that container exits. And then I can return the exit code and make decisions with that. So now I can just run arbitrary containers in the cloud, which is kind of nifty. I've got update, does exactly the same thing. I expect them to be idempotent, but I can also do a delete as well. And the final bit of the puzzle is you can implement a diff function, and this allows you to actually diff the old state and the new state and tell Pulumi that there are changes or not. So I am saying, yes, there's changes, and it will run this every time. So that's my content API database, and the database migrations is exactly the same. The only difference is it also depends on the create database task. So this has all succeeded now, and it's created a whole bunch of stuff. But I have an API endpoint that is my output variable. So we'll grab that in a second. Then finally, I'll go back to my app, and I want to create a elastic load balancer with it. That's the publicly accessible endpoint, which we've just outputted. And I also want it to run a Fargate service, which is actually a container that continues running. So if we jump back to Postman, we've got we can throw in this API, send it a post to say, I want to create this article, article heading 2, and then I'll go across to my API, and I have it's returned. I don't know what happened to the second one, but it's created one. So there's a whole bunch of things that have happened there. If we go into the Plumie state, or the Plumie website, and look at the timeline, it gives you a timeline of all of the things it is doing. So if we look for, it's creating all of these resources. If we look for create DB, so this is the task definition. It's created the run migration, all of the things to be able to execute it, log groups, keep going, down the bottom. And then you can see my task, before here. Yeah, these are my dynamic resources. So the first one, it creates the database task. The second one runs the migrations. If I jump over to the resources, it will allow me to go over here, back to AWS, go to ECS, which is the container service. I can go into my Fargate cluster. You can go to the tasks, go to the stopped ones. Oh, wrong cluster. You can see that my run migrations and create DB. So if I go into create DB, I can see the logs, and it said creating the DB. So now my database is actually managed through my infrastructure as code module, which is really, really cool. Does that make sense to everyone? Cool. Done this before. So we've seen a whole bunch of stuff. We saw Pulumi crosswalk, which is like an all batteries included. opinionated and out-of-the-box kind of good defaults. We've seen stack references that allow us to reference state and created resources across different projects, stacks, projects. We saw briefly the config system. I didn't go into secrets or any of that stuff. There's a lot of services around that. We saw component resources that allow you to compose these lower level services into higher level logical services. And the nice thing is, because we're in TypeScript, you can just write all of your services and then extract them into a class constructor. And now you can refactor your infrastructure really easily. We can create dynamic resources that wrap APIs, and you don't have to kind of build your own Terraform module and then include it and all of those sort of things. You can do it inside your Pulumi application. And we also touched briefly on inputs and outputs. Because you haven't created a service yet, it gives you kind of a future, and you can transform that future into other futures to kind of compose these different values. The code is available up on GitHub. There are a bunch of resources in Pulumi's GitHub. I highly recommend, if you want to get started, have a look at their programming model and on their intro. It covers a lot of these concepts, the input, the output, and kind of a lot of the ideas behind it. It's really important to understand that. And then I mentioned that you can unit test your infrastructure. So there's a blog post written by Joe there. So thanks very much. Probably have time for a question or two. Back. All good. Yeah, so the question was around like how does Pulumi, if someone makes changes to things, can it detect that and update its own state? So the CLI has a Pulumi refresh, which all of those, like if you've got dynamic resource providers, it's got a check function that actually can sort of make sure that the real resource matches what the state has. And that's my understanding. So as far as I understand, the Pulumi refresh command will allow you to update the state and sort of make sure it reflects reality, and then it will undo those changes. Mm-hmm. The question was, can you see that? I actually don't know. It's a good question. I can have a look and ping me on Twitter and I'll find out for you. So the question was, is there a similar concept to modules in Pulumi? So you can, like your component resources that pull things together in logical resources, you could put that into an NPM module and publish it onto NPM or into Nexus. And then so my plan for our internal stuff is all of our queues and topics are set up exactly the same way. We've got the same retry policies and that sort of stuff. So we call it snacks for SNS and SQS. So I'm planning to create a snacks module, so I can just go new snacks, pass it some basic config, and then that is published on our internal Nexus, and all of our projects share that. I'm not super familiar with Terraform's modules, so I can't create a direct comparison, but that would be the way that I would approach sharing of infrastructure. Yeah, so it's a really good question around like, well, I've got a deployment tool that does orchestration of these different things already. Why would I move all of that sort of stuff into a Pulumi module? And the main reason for me is if I am using Octopus Deploy to orchestrate that, now my agents need to be able to connect to my database. So the main reason I'm putting it into Plumie is because I can run it inside my private VPCs, which are not exposed to the world, and then they can access any internal and hidden infrastructure. So that's probably the main driver for that, because I went down the road of, and the way we do it currently is we connect to the database and we just have, like, we can only run our database migrations if we're in the office because we've got VPNs and stuff all set up. So I really wanted to get away from that. Cool. I'll let you, one more. So the question is, if you've got Terraform already, how reliable is the interop? I haven't used it. So a lot of our Terraform is we don't reference Terraform state within our Terraform. We kind of provision some infrastructure and then we make the ARN a config value. So we don't reference it directly. So because we do that, I've just moved those ARNs into Pulumi config and we're not querying our Terraform state directly. That said, they're quite motivated to make sure there is high interop. So a lot of the Pulumi modules, like all Terraform modules, they've generated Pulumi modules to be able to use those Terraform modules. So Terraform is quite heavily integrated in Pulumi already. So I'd assume it would work quite well. Thanks, everyone.